Hello, friends, and welcome to Taste of Science, an event series to feed your curiosity. My name is Pambe Bahia, and I'm the National Director of Taste of Science. But today I'm delighted to be hosting for our newly reformed San Antonio chapter in Texas. Today's guest speaker is also one of our chapter volunteers, so working hard both sides of this event. Dear audience, please welcome today Dr. Meenakshi Chinatambi Muthukarapam, also known as Dr. Meena.
Hi, Paramveer.
Hi, Meena. How
Thank
are you?
Yeah, doing good and feeling awesome to be here sharing, about sustainable material with you all. I'm very excited to be here and excited to welcome all the audience on behalf of Taste of Science San Antonio Chapter 2.
Fantastic. So, for our audience's benefit, Meena is a former professor who's currently working as an online instructor and instructional designer. She's a materials engineering researcher and she works on natural fiber reinforced composites. She'll get more into that later, but tell us how you ended up working in this field, Meena.
Yeah, Paramveer, that's an interesting question, actually. I started my research 10 years back, or at that point when I was thinking that I should contribute something to the renewable energy system like wind turbine or solar panel. That was my interest that time, 10 years back. When I started learning or reading about those systems, I understood that renewable energy system are really not completely sustainable based after seeing the materials used in blade and how much of polymeric material is there in the blade. That really got my attention. From there, I started moving into the area of how to replace that with the sustainable materials, especially using plant fibers. That's where I started into that area of research, and the journey continues still.
Wonderful. I'm very excited to hear about this.
Yeah.
But before we get started, a quick reminder to our audience so that they can please leave their comments and the questions in the chat. And once Meena has finished with her presentation, we'll be able to pose those directly to her. So whenever you're ready, Meena, tell us more about how we can use plants to make life more sustainable.
Yeah, I am ready. Absolutely. We can go into the presentation. And thanks for the wonderful introduction, Param.
Of course.
Let me present my slides. And with that, we go directly into the. Yeah. Yes. Today, let us discuss about how material matters. This session is going to be an interesting session explaining how material is important, physical material is important. Basically, I have planned this session in three part. One, explaining what is material is or why material is important. The second part are the story moves towards what is this era is, what composite actually is, or why this era is composite material. And the third, the conclusive part will explain about why that composite material has to be sustainable. We'll see this story of material today. With that introduction, let me go into why material matters. You see, this is our early invention, the stone. Today, we are using mobile phones of different varieties. All this technological development or engineering development should be supported by advancement in material. Otherwise, we, mankind, would not have moved in this ladder of technological development this far. So, any advancements in manufacturing, in aerospace, and automobile should be backed up by material advancement to make the whole execution successful. That is, I can explain this more with this, you know, this life cycle of a new product. For example, let us take a mobile phone. We want a mobile phone of very lightweight. This idea will come into the mind of a creator. Why can't I create a mobile phone which is very light in weight? From there, the points or the different ideas will be collected. Maybe I can reduce the size of the mobile phone. I can reduce the dimension of the mobile phone. We can reduce the size of a battery. We'll list all the ideas and we'll be narrow down it to one or two ideas which will actually help us to achieve this idea of a lightweight mobile phone. And we'll design the product. There comes, once the product design is ready, we have to print this design on a material or on a physical matter. Then only we'll get the mobile phone in our hand. So if this material is taken out from this cycle, this will stand as an idea. This will not come as a physical product for the society to use. So material plays a major role in giving a physical structure and physical shape to any technical and engineering idea we have in our mind. That way, material plays a very major role in engineering development. Conventional, in the early stage, in the early mankind, we started using metals. Actually, I should say we have started with ceramics, composites, and polymers. Totally metal took over the whole material world. And we are using metal for a very long time. And this century, we are slowly understanding what is wrong there and we are moving towards other material. This I can better explain with this chart. This is called as by chart. We material researchers are very much attracted towards this chart. This chart explains about the usage of material from 10,000 BC till this 2020. If you see the graph in the starting in the BCs, in 10,000 and 5,000 BCs,
Hi, Meena. Sorry to interrupt, but I don't think your slides are advancing.
Oh, I'm sorry. You are in, am I in the sixth slide or in which slide?
No, it's the first one.
I'm sorry. Is it advancing now, Paramit? I'm sorry about that.
Okay, I still see the first slide.
Mm-hmm.
Okay, now you're moving through.
Yeah. Oh, sorry about that. I don't know what happened. So hope you guys have listened what I explained. It is about the usage of material and how material evolved from a stone age to the new mobile phone age. And I explained about the steps in the new product development from idea to implementation of a product. So once we designed a new product, that has to be printed over a material. Then only the material will take physical shape and we can use that in the society. That's this I am saying to emphasize the importance of material on in engineering development. By that way, we can say a lot of materials are in use today. If you see this is a graph which is called as by chart. This graph will shows how material is being in use from 10,000 BC to 2020. In the initial stage, we can see there is a lot of options that ceramic, composite, polymer, and metal. In the 1000, the whole industry started, the engineering development started revolving around metal. Once we started mining a lot of metals, the whole industry started revolving around metal. And in the 90s, end of 90s, we identified that the depletion of raw material is going to be a very great problem. And we started moving towards other materials like polymer, composite, and ceramic again. So this bandwidth of polymer, composite, and ceramic is again increasing. Why this is happening actually? Selecting a material for an engineering product depends on many factors. The first thing any engineer will look for in a material is its performance. Will this material perform as I expected? That is the first question every engineer will have when we choose a material for an engineering application. Slowly, we engineers started realizing this is not alone the one question we should ask ourselves. There should be a lot of factors that should be considered while selecting a material. This understanding came from the factor that the depletion of raw material is happening on the earth. And the mankind started realizing the importance of using eco-friendly materials and importance of safeguarding the environment from different hazardous and polluting materials. All these factors came into surfacing around the engineering material selection field. So we started looking for new materials. Even though we got the concept of eco-friendliness, we got the concept of safeguarding the environment, still the high performance and that wear and corrosion resistance in a material are we consider as important factor. The one more factor which came in this new generation of engineering product development is lightweight. The product we are developing should be of light in weight, lighter the product, efficient the product. So all this factor pushes the engineering industry towards new material. The one material that attracts the industry more is composite material. That composite material is what we are going to discuss about today. One interesting question I want to pose to the audience. The answer is here actually. What is US penny made up of? It is mostly of zinc. Actually, copper is what used in the early stage. As copper become more expensive day by day, the penny making industry moved towards zinc. The cost of a copper used for making one penny is more than a penny. So they moved towards zinc. The modern 1 cent coins are a sandwich of zinc between two layers of copper. This is an example for how the change in material world is happening. With all this in mind, let us move towards the new age material, composite. Then what is composite? I am using this term from the starting often. The composite is combination of two materials together to make another more efficient or more stronger material. One portion of the composite is called as a matrix, which is shown in the picture. The other portion is called as a reinforcement. This matrix is called a kind of body of the material, and the reinforcement will act as the strength component of the material. When you combine these two, a new material will be formed. This will have the advantage of both the components, both the individual components. That way, this becomes more superior compared to the both individual component. This type of material is called as composite. A combination of two components, which will give a third one, which is called as a composite material. But this concept is not completely alien to us. We have a lot of natural composite here. Our bone, the bone in our body, is a composite material. It is made up of the more strong and a hard and brittle calcium phosphate with a soft and flexible collagen. The bone is the best example for composite. Likewise, the wood, the stem of a plant, if you take a stem of the plant and see that, there will be white spongy material inside, which is cellulose, and outside is called as the green lignin. This is a composite material. So this composite is not a completely alien to us. Using this concept of combining two material and getting another material, it is very advantageous. You can kind of tailor make the material according to your requirement. So that's how composite gains the attention of engineering industry to consider that as an engineering material for many of the applications, because it is like kind of man-made material. You can combine any two things to get your requirement and use it in your application. So we used to say that as tailor-made material. So that's what composite is. Let me move and show you more pictures. These are different types of composites. You can see here a box. This box is the matrix, and inside small particles are there. This is particle reinforcement. Similarly, there is a box which is called as a matrix, in which a lot of small fibers are there. This is fiber reinforced composite. The bottom one is very interesting. This is called as structure reinforced. This is what we are using in the front bumper of our cars. The honeycomb structure, the web-like structure inside, will have a lot of impact resistance. If you put that in between two sheets, it will make a composite. The same corrugated box which we are using, that is also this type of composite material. So these are different types of composite. To make it more clear, I can classify the composite into three types. One is particle reinforced, which we saw. Again, we saw the fiber reinforced one. The third one is structural reinforced. You can use a particle of very large size, which is called as large particle reinforced composite. You can use a particle which will disperse and give us strength, that is dispersed composite. You can use fiber of long length or fiber of shorter length. Fiber aligned, fiber pour random into the matrix, structure with laminates, sandwiching something in between two panel. These are all composites. So at this point, you might have understood how versatile this material is. You can take two materials and you can put it together and you can make the third material, which is going to be very stronger than the initial two components. Only thing, we should know the process of doing this combination. That is called composite fabrication process. We will fabricate the composite as we need. Here comes the major components or the major type of elements we are using nowadays in composites. One is called as fiber, and the matrix is called as resin, a liquid material. We will pour this resin. This resin is a polymeric resin, either made of, you can use polyester as a resin, epoxy, which we commonly see in our hardware store. You can use that as a resin. If you pour this over fibers and allow it to solidify, some polymers will solidify even in room temperature. If you allow it to solidify, and you will get a new material that is called as polymer matrix composite. This is highly used in most of the industries nowadays. The picture I have kept here, the white color is glass fiber, glass and fiber shape. The black color is carbon fiber, carbon in the form of fibers weaved together to form a mat. This is strands of glass fiber. So this two any of this can be used, or I would say these are the two most commonly used fibers in today's products, along with these synthetic resins. This is the global consumption of composite by automobile industry. This is starting from the year 2013 to 2030. This is how it is expected the trend is going to grow. The carbon fiber composite, the thousands of ton in the y-axis will show you how much of composite, especially carbon fiber composite, we are using in automobile industry. This is not only for automobile industry. The same trend is growing in many of the sports good manufacturing industry. The ski board we are using, the rackets we are using, the cruise and the sports ship we are using, everything is made up of composites. If you see here in the ship, the upper deck, the deck surface or the floating deck, the wall inside, everything is made up of composite material. So this how predominant composite is there in the market. This trend is because of certain factors. One is it is very light in weight. Another one, it combines the advantage of two materials, which will give you a very superior performance, which I already specified. Any product when we are making, we will stick on to the structure strength requirement. So this composite is meeting the strength as well as it is giving a very lightweight material. Hence, this is predominating the market, or this is dominating the market in many way in many of the areas of product development. Yeah. One more question. Do you know a metal cry when you bend it? Yeah, one of the metal really cry when you bend it. If you bend tin, it will make a moving sound like a cat. This is because the metal tin will bend with a process called twinning. The molecules will go into a process called twinning that will cause a sound. That sounds will resemble like a cat moving. So tin is called as a crying material. This is just a fact for you. So now we know what is actually material is, how important material is in any engineering development, and how composite is playing a role in engineering development and new product development, and how it is dominating the automobile industry and sports good manufacturing industry and aerospace also using a lot of composite material. So this is what happening in today's era. Now comes the question why this has to be sustainable, or why there should be green element in this material, or what is the problem actually in this material. Let me take this example, this wonderful example which pushed me into this, or which make me turn towards this research. If you consider a long wind turbine blade, if you take one blade which is of 45 to 60 meter long, this will be of 20 to 35 ton of plastics, mostly plastics otherwise. The life of one wind turbine blade is almost 20 years. After 20 years, this has to be decomposed. This has to be disposed actually. We will dispose this, most of the part, as landfills. Recycling is there, but it is happening in a very less percentage. So you will be dumping this in the land. Imagine how much of plastic waste we are dumping inside the land. I'm speaking about one blade, which is of 20 ton. A horizontal axis wind turbine blade will have 3 blades, and the whole world is increasing the wind energy production in a very higher percentage. Countries like India, Europe, the whole Europe, even United Nations, we are all trying to harvest a lot of energy from wind by installing a lot of wind turbines across the world. If that is the case, consider today we are installing 1,000 wind turbines. At the end of 20 years, all the 3 blades into 10,000 will be deposited on the land. See the amount of plastic waste it is going to be creating, or how much the earth will be affected because of this. There comes this problem. One more factor. When you take the life cycle assessment of these products, starting from taking raw material for producing a wind turbine blade or a car, whatever, you will produce the fabricate the product, you will do the manufacturing, you will use the product, and you will dispose it. This is a cycle of any product. From the starting of producing the product till the disposal, there will be lot of emission possibles, lot of non environmental friendly emissions possible. So, for example, when you manufacture this polymer matrix composite with glass and carbon fiber, during the process of manufacturing, lot of steroid will be emitted. Styrene emission will be there, which will cause a lot of problems to human being. Likewise, in many of the production stages itself, lot of non-sustainable activities is there in the development process. So in the disposal as well as in the production process, these material brings a lot of environmental issues. This forced the nations to bring lot of regulations to implement sustainable development. These issues of creating unenvironmentally safe material or not environmentally friendly material force the nations to put lot of norms for the emission of harmful gases, as well as put lot of regulations in decomposing these materials. This leads to the development of another type of material, which is natural fiber composite. So, as I said, in composite, we use two materials together. One is the matrix or the resin portion, along with we are combining the fiber. Instead of using glass and carbon, we can use fibers from plants. If we use fibers from plants and combine it with the resin, it is called as natural fiber reinforced composite. Of course, you may ask me a question. This resins or the matrix are again polymers. Yes, worldwide, lot of research are going to even replace the synthetic polymers with the resins from natural sources like cashew nut resin. Lot of research are happening throughout the world. If we replace both the component, it is completely green product. At least now we can try to use, or we can try to replace the fiber with natural fibers, which will make or which will improve the biodegradability of this material. There are why fiber, you may wonder why you are speaking about using fiber, because fiber is easily available. We can harvest this fiber by harvesting those plants. That will indirectly give a lot of opportunity, agricultural opportunity. We can use agricultural waste as reinforcement in this material. So in that way, this is a win-win situation for both for engineering industry and for agricultural development. What are the possible fibers then? The natural fibers we generally classified into two types, plant fibers and animal fibers. We used to recommend plant fibers for engineering application. You can use fiber from the leaf for as reinforcement in polymer matrix composite. Fiber from the stem and stalk and seed you can use at reinforcement. The flax seed we are seeing in our supermarket, the stem of the flax seed can be used as fiber. The cotton can be weaved into fiber and can be used. Rice husk can be used as a reinforcement. Jute and hemp can be used as a reinforcement. So just replacing that glass and carbon or any synthetic fiber with this natural fibers will improve the biodegradability of the material. These are some common fibers which we used in our laboratory. The first one is banana fiber, the fiber from banana stem. The second one is called as bagasse fiber. This is the waste of sugarcane crush. The third is a glass fiber mat, which is actually in existence nowadays. This we use for comparing between the performance comparison. We made a product with glass fiber as well as natural fiber, and we compare and see what is actually the performance of these products. And here the fourth one is bamboo fiber, and the fifth one is again a strand of glass fibers. I'm sorry. And the last one is flax fibers weaved in the form of mat. So these are the possible fibers we can use, and many more fibers are there which across the world, lot of researchers are using lot of fibers. We can use the fibers from aloe vera plant, we can use the fibers from sisal plant. All these fibers are there. Usually the norm here is whichever agriculturally is possible in the geographical location, we can use that fiber. Whatever agriculture waste is highly produced in that country can use that fiber as a reinforcement. So using these fibers and the resin, we can make composites like this. These are composites plates we made. The first one is with flax. The second is flax and glass. Likewise, we made composite plates with lot of combinations. I already spoke about the importance of strength. We can harvest the fiber. We can improve the environmental friendly nature of the material by using natural fibers. But at the end of the day, the material we are creating should be strong enough to withstand the application's load and pressure. For that, we have to test those fibers, and the testing has been happened. We test the tensile, flexural, impact, and water absorption behavior. Tensile strength is how it is resistance to breaking when you are applying a load. Flexural is how it is resistance to bending when you are applying load. Impact is when you impact an impact load, a sudden load is applied, how much it will withstand. What is the water absorption capacity of this material? This is very important when we want to recommend something as a engineering material. Any engineering material will undergo all this type of load. So we should actually, the material should actually able to withstand this load. We cannot just recommend such material for engineering application because just it is bio-based. It has to withstand the load going to act on the structure. And we tested, these are the test values. If you see something I have highlighted, the one with the flax is having equal tensile strength like another one with completely glass. The one with canaf is also having equal strength like with glass. That shows this material when properly fabricated will bring at least equal strength like the synthetic counterpart like glass or carbon fiber. So this is a proof that we can use this material instead of using a completely synthetic material in high engineering structures. And the interesting part is we were able to make some of the products which is highly using completely synthetic polymeric composite. We have seen this small gears in the Thai cars our kids are using, in the Xerox machines. Those gears are made up of polymers. We replaced that with natural fiber, and we were able to produce that successfully with the fibers. In the gear, we used fibers of small strands. The same we did in the wind turbine blade manufacturing also. We produced 3 blades, one with flax fiber, one with the sisal fiber, and one with canaf fiber. So we produce these products, and it is a proof that, yeah, we can reduce the synthetic content in any material which is being used in engineering application. If we do that, automatically the environmental friendliness of the product will improve, which will safeguard the sustainable development, or which will contribute to the sustainable development of the society actually. This is not only our idea, this is not just a research idea, this is not just in research form. A lot of major players in the market are doing this nowadays. BMW, Ford, Renault, Volvo, they are using natural fiber composites to make their doors, like front door, rear door, and seat backs. Jute fiber is being used by Mercedes even in 1996 to make the door panel. Daimler is the first one which uses complete plant fiber to make cars. to make recyclable cars. Valvo is working on reducing the weight of a vehicle by using natural fiber composites in its vehicles. So these are some practical examples where we can use natural fiber composite. So the more natural fiber composite in the products in the automobile, the cost will be low, less carbon emission, eco-friendly, and it will give you a very green vehicle actually. So many of the automobile industry are slowly moving towards this application, and really that will give a very sustainable development. Instead of depleting the natural resources we have, we can do engineering with something which is environmentally safe, which is environmentally friendly, which safeguard the environment. Uh, uh, for that, natural fiber composite will be of great help. US has taken a lot of steps towards this. The United States Department of Agriculture is doing a lot of fiber research. I think it is considering more than 30 type of fibers to use in engineering applications. The company called FiberX has found out that South Virginia has a lot of potential for producing hemp fiber. It is one of the type of natural fiber to use in packaging, automobile, construction, and in textile industry. So United States is also contributing to a lot of natural fiber development actually. So by that way, I am hoping in a few decades we will be using natural fiber composite in most of the engineering application, and will do sustainable engineering. Hope I explained the topic clearly, and you got an idea what is natural fiber composite is. Thanks for listening. And if you have any question, you can post it in the comment section. Thank you so much.
Thank you so much. That was great. And I like to think of myself as someone who's kind of informed on environmental issues, and I didn't realize any of this technology was in existence. So that was wonderful. So we have a few questions in the chat, but before we go into those, I have a quick one for you. Quite often when we're trying to make changes with regards to sustainability and making things more environmentally friendly, we have this kind of, we then later discover that the thing that we're trying to solve is causing different problems. So for example, with natural products, is there the possibility that you end up suddenly using more water to grow the plants that you then need? And so this creates its own issues for the technology.
Yes, that's a very fantastic question. Yes, often we end up finding the problem in the later stage of after development. And that's a great question, Paramveer. I would say for this, in this aspect, instead of growing plant exclusively for producing engineering product, we can use the plant which it's a mandate, like the products which like rice. The straw we can use for making engineering product. Flax we are producing for consumption. The stem of the plant is a waste. It's a bio waste. We can use that as a natural fiber product for natural fiber composite fabrication. The sugarcane we are producing for making sugar. You can use the crushed waste as bagasse fiber in natural fiber production. In that way, we are not producing exclusively for making natural fiber composite. That is one answer. Another thing is, see, when using this natural fiber composite, even in laboratory, maybe I can prove this is having the same strength as the synthetic counterpart. But when it comes to application, yes, there are some coating techniques industries are using over the natural fiber, which will again question the sustainability factor. So researchers are working on even avoiding such treatments just by treating the fiber in the right way and using that as it is to reduce the effect of the synthetic on the sustainability. Yeah, research is going on. This is what I can say, I think.
No, that's tremendous. I love the idea that you're actually just using waste products from somewhere else, uh,
Yes.
and giving them some use. So, as I said, we have some questions from the audience, but quickly before that, we would like to say that you can follow Taste of Science San Antonio on their various social media platforms. And if you go to the website, tasteofscience.org/San Antonio, you can sign up to the mailing list if that's your jam instead. They will have more events coming up for you in the future.
Yes.
But yes, on to our questions. So the first one I see here is from Jay Hawkins, who says, is the process to make natural fibers faster than synthetic?
Yes, actually, that's a great question, Jenny. The process of making natural fiber is more simpler and more faster, and I would say that will open a new type of industry, like small scale industry, using the indigenous people and agricultural people. The complaint in the world, in countries like India, is after a portion, after the period they do agriculture, a few months they left without job. During those time, we can use that people to create the natural fiber, to process the natural fiber and produce the natural fiber and use it in engineering application. There are like cooperative societies, like communities here. There are like cooperative societies. Even UN is supporting a lot of such small scale industry to develop larger natural fibers. What I am trying to say is, it don't need a big industry or big manufacturing setup to produce natural fiber. You can just bring the fiber, dry it in sun, make the water go off, you process it in the vessels you have at your home, and weave it with hand and make a mat and give it, like our decor products, the jute decor we are using. So it's really a simple and very domestic process, which don't need any large equipment or investment. By that way, it will open a new avenue of employment for underprivileged people, I would say.
Yeah, that's just such a tremendous economic kind of upside to the whole
Yes.
process. And this is not directly related, but we have a question from Shamika, which says, how would this, I guess that's okay. So we're going to, are there any financial upsides?
um you know can you repeat the question, Paramir?
Yes. So, are there any financial upsides to using plants rather than kind of the synthetic composites you were talking about?
Yeah, if I got the question correct, she is trying to ask, will it reduce the cost of the product?
Yeah. So there were two
Yeah,
related questions, and the other one
yes.
was, how would this affect the consumer's financial? Like, would there be an increase in price or decrease in price for the people who are then buying the product downstream?
Hmm. Yes, that's a great question. Yeah. Actually, as this product, anything when it is coming into the market, this is high cost, the product will be in the, it's like something unique, or this is like now we are seeing no everywhere organic, and we are paying extra $2 for getting an organic blueberry. The same thing is now happening in natural fiber composite in engineering products also. But I am sure when this awareness among the industry increase, when the success rate of using natural fiber composite increase in industries like BMW, Valvo, all the manufacturers will start using this product. Automatically, more the product, lesser the cost of the product, which is sustainable. This, I would say, this is same as like organic consumable product at this point. Maybe with in future, this is more accessible to common public. Yes.
Wonderful. So the next question we have is from Ian, who asks, what are some of the challenges with using natural composite fibers in manufacturing?
Yeah, that's another wonderful question, which researchers are, working so hard. One of the very great difficulty in manufacturing or using natural fiber composite is, let me take again the example of wind turbine blade. Wind turbine blade will be in open atmosphere throughout its life. When you put a natural fiber on a blade, this fiber is exposed to extreme condition like extreme heat, extreme cold, extreme water. So these extreme condition will affect the natural fiber's life more than its synthetic counterpart. For example, when you install a wind turbine made of natural fiber in a very rainy area, the fiber may tend to hold the water inside, and the blade will bulge and peel off. This is one common problem we will face when we use natural fiber. To eliminate this problem, now we are using a lot of coating techniques to avoid the natural, to prevent the natural fiber from retaining the water. There where now research is happening how to do in a very sustainable coating, or how to do that. This is one challenge we are facing with natural fiber. Likewise, there are a lot of challenges. Another logistic challenge is continuous supply of natural fiber. Yeah, it has lot of challenge on its by with it.
Great. Yeah, I mean, I guess any new technology is going to have its
Yes.
teething pains, right? So the next question we have is from David, and that is there a future where all the main materials we use to build buildings are based on natural fibers, or will we be using concrete for a long time to come?
I think now concrete is being replaced by a lot of other materials in construction. Yes, actually, they are trying to bring. I have read in a few research articles that there are some buildings in South Africa which is completely made of natural fibers. Uh, but I think that will take a long time to use it construction industry to such extent, because this is not only the option in construction industry. Maybe in automobile industry this is one of the predominant option, but construction industry has a lot of other options too. So maybe a light of wobbling is there in using natural fiber composite, but I seeing composed wood is being highly used in construction in America. Yeah.
So I think that's all the questions we had from the audience. I was just wondering if, do you have any kind of final words that you'd like to share with us before we sign off?
Yeah, absolutely. That was wonderful sharing my idea of natural fiber composite with all of you. That was a great feeling, actually. Uh, at this point, I would say natural fiber composite is still in research state, and a lot of industry are taking bold decisions to move towards the environmental safe material in their product. We, as public, we should also, gather our confidence to use that product. We should not think this may not be, we prefer products which look high end. We should prefer more products which look more sustainable than which look more fancy, I would say. This is my final note.
Wonderful. So essentially saying, don't be a snob. Green is good. That's what we
Yeah.
like. Well,
Thank you.
thank you again so much for your time, Meena, and thank you to our San Antonio team for putting this together. I know they've put a lot of work into it. We very much look forward to seeing you all in the future.
Yeah, thank you so much. Thank you for the opportunity, actually.
Okay. Bye all.